Hello, guys. Welcome to the first episode of GCP and You. In this series of episodes, I'll be helping you learn about GCP and how you can improve your hands on experience on GCP. So, today I'll be helping you learn how to create a virtual machine. So, before we go to make a virtual machine, we'll first learn about what a virtual machine is and how it can be used. So, virtual machine is nothing but a basic emulation of a computer system. So, maybe you have your own laptops and desktops. So, a virtual machine is a emulation of the same. So, you get to create a machine which gives the same output like you get in a physical machine. So, in a VM, you get the option to choose your machine configurations. You can decide the amount of memory you need, you can decide the amount of CPUs you need for higher processing. Based on your processing, you can choose the configurations including the operating system. So, virtual machines services are given through Google Cloud's Compute Engine. So, let me tell you about Compute Engine. It's a service provided by Google to create and manage virtual machine instances. So, Compute Engine will allow us to create virtual machines on different operating systems, and we can run any number of CPUs in order to get the desired performance of our system. So, before creating a virtual machine, we need to look into some of the concepts which are very much essential. So, the first concept is the concept of regions. So, compute engine resources are distributed across regions and zones. So, a region is a part of a specific geographic location where you can run a resource. So, each region will have one or more zones. So, these zones represent a physical data center. So, all those zones will have a physical data center of the cloud service provider. So, here we can see the different regions in blue boxes. You can see Western US, Central US, Eastern US, Western Europe, and Eastern Asia. These are some of the regions which are provided by Google Cloud. And inside that region, within the region, you have different zones. So in Western US, you have US West 1A and West 1B, and in Central US, you have Central 1A, 1B, 1C, 1F. So you have different zones and regions. So what you have to remember is that you need all these parameters to create a virtual machine. So to attach a persistent disk for memory, both resources which you create must be on the same zone. Also, if you want to assign a static IP address, the instance must be in the same region as of the static IP address. So here I'm taking a quick labs small lab which gives you the guidelines of creating a virtual machine, which has already been completed by me. But to take an example, I'm going through the example given by the quick labs. So to create a virtual machine, what you have to do is we have to go to the compute engine and then go to the VM instances. You can do it either by console or through the cloud shell. So first of all, I will show you how to use through the cloud console. So what you see, this Quick Labs GCP 03294C77FCC A67 is the project which you are assigned. So every resources run on GCP will have a project. So to create a VM instance, we'll click on create. Okay, now the first thing is the name. So we have to give a name. So we will give GCE lab, and this is labels which you can mention the instance as labels, like you can give some labels assigned to the instance in order to recognize it in a later stage if you are using multiple instances. Next is the region and the zone, which I have told earlier. You have to mention a region and a zone. So here you can see the pricing of the instance. So everything is priced. We have to pay for what we use. So this configuration will have monthly cost $24.86. So we'll see the different configurations. So next is the machine configuration, which is divided into three machine family types: general purpose, memory optimized, and compute optimized. So each has its own properties. So in general purpose there are different series, and in those series we have different generations. Is the first generation is N1, and the second generation has E2, N2, and N2D. So here we'll create an N1. So inside N1 we have different machine types. So this machine types specifies the memory and the number of CPUs. So we can either create it by custom, where we can select the number of CPUs we want. We can give up to 96 CPUs, and we can choose the memory also up to 6.5 GB. So we can, and this is a shared core which shares the memory and also the CPU. So we have F1 micro and G1 small, and each has its own difference when we look at the cost. So now, as you can see, it's about $4.28. From 24.86 it went to 4.28. So that is the difference it can make. And if we go for N2, we'll have different cost. Again, coming to memory optimized, we have different machine types based, and these are given for memory optimized programming, and this is for compute optimized programming. So our example is to create a GCE lab instance on US Central 1 at the zone US Central 1C. So this I can choose as Central 1 and 1C. Now the machine type, the machine configuration is given as series is N1. So the series is N1 and 2 vCPUs. So this is a standard N1, standard 2. That is the name of the machine type given. So we'll choose N1 standard 2, which has 2 CPUs and 7.5 GB memory. Now there is a confidential VM service provided. If we can enable, we can implement confidential computing, and this is a container option which will help you to deploy a container image to this instance. Next is the boot disk. So in this boot disk we have different types of boot disk available. We can create a boot disk from an image. We have custom images which can be made, and we can have snapshots which is the configuration of a virtual machine at a given point of time. And we also have different existing disk option which we can create. So here we have given as new 10 GB standard persistent disk of OS images Debian GNU Linux NAND stretch. So we'll select stretch, but we have different operating systems. We can create any boot disk of these operating systems available. So these are the services available by GCP, and we have different boot disk. We have standard persistent disk, SSD, and balanced, and also we can give the size of the disk. So we select it. Now that is selected, now is the identity and API access. So this will give you a service account option. So compute engine requires a service account to give its scope and of the access of the virtual machine. So service account will control all the actions inside this particular instance. So we have service account, which is the compute engine default service account to manage all the actions inside this compute engine service, and we have access scope, which we can give as to access each APIs. So we can either set access for each APIs of these services, or we can give access to all cloud APIs, or we can give default access. So next is the firewall, where we can give the network, we can specify the network traffic which comes through the instance. So in the example given, we have allow HTTP traffic. So we have to allow HTTP traffic. So this allows the instance to allow the traffic through the port 80, because that is the port which supports HTTP. And we have management security disk and sole tendency, another additional options given by Google Cloud Platform. So in this management, we can give a description, and this description is meant by a description of the virtual machine which we are making, and deletion protection to enable, and if we enable it, that instance won't be deleted. And also we can use reservations, which we can automatically use and don't use. And to the automation, we have startup script, which is to specify if we need to install something before setting up the instance. So as a startup script, we have to mention the script which we need to run. So this will install all the softwares and updates and all those things. And there is a metadata which we can give as a key value pair. And then we have the availability policy, which has three parameters: preemptibility, on-host maintenance, and automatic restart. So preemptibility, when we switch it on, it will become a preemptible VM. So this preemptible VM will be shut down after 24 hours. So this preemptible VM is a service provided by GCP for short functionings, where the given task is takes less than 24 hours to complete. Then you have the automatic restart option, where you can restart the instances if they are terminated for any other hardware failure or any controlled event. And also on host maintenance, where you can indicate if the virtual machine should be migrated to another physical server um, during a maintenance. So this is the management part. Now we'll go to the security part, where we have a shielded VM. So shielded VM is configured to have an additional security mechanism. So it has a secure boot, which ensures only authenticated OS will run on the VM, and it's checked by a digital signature. And there is VTPM, which stands for Virtual Trusted Platform Model, which is a virtually trusted platform model. So trusted platform model is a specialized computer chip designed to protect security resources. And integrity monitoring, so it uses known baseline of boot measurements to compare to the recent boot measurements. And we have the SSH keys to specify, and we can give the we can block the project wide SSH keys, which will block those SSH keys to access the instance. Then we have disk. So this boot disk has a deletion rule, which we can enable to in order to save the disk from being deleted if we accidentally delete a VM. And we have encryption, where we can either give a key which is managed by Google, or we can give a managed key by ourselves, or we can give a key which is managed by Google Cloud Key Management Service. And we can give the device name. And then on networking, also on disk, we can attach an existing disk or a new disk to the instance. So in networking, we can use networking tags, which we can add for firewalls and other rules, which we will deal later. And we have network interfaces, which we can mention on which network it should run on and which subnetwork which would run on, and the internal IP address and external IP address, so which we will deal with later. And we have sole tenancy to ensure the VMs run on a server only with other VMs. So these are the basic things about a VM, and now we will create the VM. The virtual machine is getting created. It will be created very quick. Yes, it's created. So here we can see that there are different options. So we have the internal IP assigned by GCP, we have the zone, and we have the external IP address, and we can connect it through SSH since we used Debian. So when we go through this external IP, we can see that nothing is currently accessible. Now let's check. Okay, now we have to install an Nginx server inside the instance. So what we do is we SSH through the instance. Now this instance is more like a server. We'll wait for the server to be established. So the connection is done. So now we'll get access to the root. So sudo su minus. Okay, now we have the root permission. Now we'll perform apt get update. Okay, the update is done. Now we'll install Nginx. So apt get install Nginx. So the Nginx server is getting installed, as you can see, and Nginx is installed. Now we have to check if the Nginx we have installed is running or not. So for that we'll use ps and find using grep. So ps AUWX, and the pipeline will see grep Nginx. There we can see on root we have grep Nginx, and www data is running on Nginx. So it is running. So now we can go to the IP address to see if this is working or not. Before we went, we couldn't access it. Now we have the web page displayed, welcome to Nginx. So the Nginx server is now hosted on this IP address. So that is how we install a server to the instance. And this is how we do it with the Cloud Console. Now, as you know how the Compute Engine works and how to create it using console, we also have another option to create using Cloud Shell. So let's initialize Cloud Shell first. So the Cloud Shell will get provisioned and it will appear soon. Okay, now we have the Cloud Shell which is given at the student level, so we'll need to set our project by the command gcloud config set project followed by the project ID which we are using. So here we will use our project ID and the project is updated. So now we'll create an instance using gcloud command. So what do we have to give? We can mention all the parameters which we have discussed so far, but creating a simple VM instance through cloud, what we need is gcloud compute instances, create the name of the instance which we can give as GCE lab 2 minus machine type space, and we'll mention the machine type N1 standard 2 and minus zone as US Central 1C. So that's pretty much it. We click OK and we authorize, and the instance will start getting created, and we can see that the instance is now created. Now with gcloud compute instances list, we can see the list of the instances which you have created and its IP addresses. Also we can SSH inside our instance through the gcloud command as well. So what we have to make sure is that we clearly define the zone of the instance which we are going to enter. So we'll give gcloud compute SSH GCE lab 2 minus zone US Central 1C. And we have now accessed the instance. So now we are inside the SSH inside the Cloud Shell. So here also, like what we did on the console, we can do the same using command shells. So if we don't need to do anything, we can click exit and the SSH will be exited. So this is basically how we create our instances. Thank you for watching. Hope you have understood so far what I have said, and if you like this video, please subscribe to my channel for more videos of GCP. Stay tuned, I will come back soon with another videos of GCP. If you have any suggestions or comments, please do comment below. Also, you can subscribe to my channel for more videos, and I'll be coming soon. Please like, share and subscribe. Thanks for watching. See you soon. Bye.